Okay, so once again, good morning to you all. Uh, so we have discussed till now basics of VHDL programming. Okay. Now that means how to write program in VHDL that we have seen till now. Now in continuation with that, we are moving forward for our second unit, that is uh, VHDL models for combinational and sequential circuits. Okay, so I'll share my screen now. Okay, so we are starting with our second unit, that is VHDL models for combinational and sequential logic design. Okay. So the contents in this topic, that is half and full adder and subtractor, then multiplexer, demultiplexer, encoder, decoder, after that comparator, then 4-bit adder, array multiplier, then latches, flip-flop, counter. In that we are going to and that we are going to discuss about synchronous as well as asynchronous counters, then shift register, static ROM, RAM, sorry, and then ROM. Okay. So these are the contents that we are going to discuss in this module. Okay. So here actually we have discussed about how to write VHDL program. That means what will be the uh, how to declare libraries, then entities, architecture that we have seen. Okay, then what are the different parameters that we need to declare? So that also we have seen in the earlier unit. So using that, how to write a program that we are going to discuss in this unit. Okay, या प्रत्येक application साठी कुठल्याही सर्किट साठी आपण VHDL program कसा लिहायचा ते आपण इथे बघणार आहे. Okay, so these are the different circuits that we are going to discuss. So books for this unit, that is, one is the Circuit Design and Simulation with VHDL by Volney Pedroni, which is published by PHS. Then Fundamentals of Digital Logic Design with VHDL by Brown Branstad. And then another book, that is a Digital System using System Design using VHDL by Roth. Okay, so these are the books that are referred in your syllabus, or that to be referred, which are mentioned in your syllabus book. Okay, but besides that, I will recommend one more book, that is VHDL Programming by J. Bhaskar. Okay, I have shared this book in a Google Sheet. If you have seen that, you can download that book and you can refer that book also. So Pedroni and J. Bhaskar. These two books that will be useful to understand the basics of this VHDL programming. Okay. Besides that two books, you can also refer these books. Okay, so these are the books that to be referred. Now, coming towards the title of the chapter. Now, what is the title of the chapter? It is the VHDL model for combinational as sequential circuit. So, actually, the key idea in VHDL is to define the interface of hardware model, okay, while hiding its internal details. So, that means we are hiding whatever is the inside, but we are defining how to interface the hardware model. So, that is done using VHDL. So to do this, for different combinational and sequential circuits, we are going to write certain VHDL codes. Okay. So as this title suggests, in this unit, you will get idea about how to write VHDL models for various combinational and sequential logic circuits. Then the central idea of this chapter is to provide knowledge of how to write VHDL model for different circuits using whatever basics that you have learned earlier. Okay. So whatever you have studied, using that we are going to excuse we are going to write a VHDL code for all these circuits. Okay, and then this chapter will help you to improve your programming skills. It will introduce all these programming skills using VHDL, and that will help you to write VHDL code for different logic circuits. Okay, so we are going to study limited circuits, but that will help you to get idea about how to write code, how to simulate it while doing practicals in the laboratory, and then you can write code for any circuits. Okay, so that is the central idea of this chapter. Okay, and then what is the importance of this chapter? Okay, so first of all, this chapter will introduce VHDL model for different circuits. That means how to write VHDL program for sequential as well as combinational circuit, that will be understood in this unit. And this is important because as nowadays most of the circuits that are digital in nature and also that are in a miniaturized form. Okay, so that means we need to have a certain language that should be known, a hardware description language that should be known by you, so that you can design any circuit. Okay, and for that this unit is important. Okay, so this chapter is important as it will help to design VLSI system using VHDL, and so that it will improve your VLSI knowledge. So at the end of this unit, what you will be able to do? Okay, so that is the most important question. Why we are studying this? मी का शिकतोय हे सगळं? So त्याच्यासाठीचा आन्सर आहे की तुम्ही at the end of this chapter you will be able to write VHDL module for combinational circuits like adder, subtractor, then and then counters. Okay, so then after that you can write VHDL model for sequential circuits like flip-flops and shift registers. Okay, so these are the chapter outcomes. That means you should be able to write this after end of this chapter. Okay, so VHDL models तुम्हाला लिहिता आले पाहिजे. That then only you understood. It is considered that you have understood this chapter. Okay, so this is about the what we are going to learn in this chapter and what are the chapter outcomes. Okay, so now before going to the actual contents of this unit, we are just going to discuss about the basic logic gates. Okay, so first of all we will see how to write a code for basic logic gates. Okay, I am going to consider two gates only. Okay, and then we are going to proceed for the next circuits. Okay. So first of all, let us consider AND gate. Okay. So AND gate has how many inputs?
Two input, one output.
Two inputs and one output. Okay. So that means A and B, these are the two inputs of this gate and Y is the output. Okay. So if we look at the truth table of this gate, then whenever both these inputs are zero, output is also at a zero logic level. If also, if any one of the uh, input of this logic gate is zero, output is zero. And output of this gate is high only when both the inputs are at high logic level. Is it correct? So that means in a this AND gate can be defined as a we can say output of AND gate is high only when both the inputs are at high logic level. If any one of the or both inputs are at low logic level, then output is zero. Okay. So for this, we want to write a VHDL code. Okay. So as we know that we have seen that we can write architecture in three different ways. Okay, so that means we can model this in a three different ways. One is the behavioral modeling, another one that is a data flow modeling, and third one that is a structural modeling. Okay, so these in these three different ways we can have a architecture of any VHDL program. कुठल्याही सर्किटसाठी आपण तीन वेळेने लिहू शकतो. तर त्याच्याप्रमाणे आपल्याला इथं पण अँड गेटसाठी करता येणार आहे. ओके. सो फर्स्ट ऑफ ऑल वी आर गोइंग टू सी अबाउट द डेटा फ्लो मॉडेलिंग. ओके. बट बिफोर दॅट टेल मी what are the different units that are present in VHDL program? What
First,
are the
ma'am,
different?
library,
Yes. Then
declaration of library. After that,
yes,
entity declaration
entity declaration.
and
Then
architecture declaration.
and architecture declaration. That means, first of all, we need to declare library. Then after that, we need to declare entity and then uh, architecture. Okay. So let us go to the data flow model. So here, first of all, we need to declare library. Okay. So by default, we are going to take a library that is a IEEE. Okay. So the first statement that will be library, IEEE, and then semicolon. Okay. So this is your first statement for the AND gate. Okay. Uh, so side by side, you start writing this code. Okay. Then next is that we need to declare which package we are going to use. Okay. So for that, we are going to use clause and then the package that is IEEE dot standard underscore logic underscore 1164 dot all and then semicolon. Now what this statement will do? It will add this IEEE package standards logic 1164 to this program. Okay. So that means we have declared library and then we have declared package. So here this is the library declaration. Okay. Then after that we are going to declare entity. Now what is mean by entity? What is done in entity declaration? एंटिटी डिक्लेरेशन मध्ये काय करायचं?
मॅम इनपुट आणि आउटपुट पोर्ट डिक्लेअर करायचं.
Yes. There we need to declare what are the inputs to the circuit and what are the outputs to that circuit. Okay, from that circuit. So that we need to define. So whatever the outside uh, elements that are present, that means input ports and output ports, that we are declaring in an entity. Okay, there may be certain signals that are present inside the box. Okay, black box, if we are considering any circuit as a black box, त्याच्या आतमध्ये कितीतरी सिग्नल्स असतील, बट वी आर नॉट डिक्लेअरिंग दॅट सिग्नल्स इन द एंटिटी, बट वॉट एव्हर आर द आउटसाइड सिग्नल्स दॅट वी आर डिक्लेअरिंग इन द एंटिटी. ओके, सो इथे आपण काय करणार आहे, आपल्याकडे काय आहे, आपण अँड गेटसाठी एंटिटी लिहितो. सो हिअर वी नीड टू यूज द कीवर्ड दॅट इज अ एंटिटी अँड देन यू कॅन गिव्ह एनी नेम टू द प्रोग्राम दॅट यू आर रायटिंग. म्हणजे तुम्ही जी काही एंटिटी लिहिताय त्याला तुम्ही काहीही नाव देऊ शकता. ओके, आता आपण अँड गेटसाठी लिहितोय म्हणून मी इथे अँड गेट हे एंटिटी नेम वापरलंय. ओके, सो दिस इज अ अँड गेट अँड देन is. Okay, this is again a keyword. Now, you can give any name to this entity, but you cannot give just A and D as a entity because it is a keyword in a VHDL. So you cannot use keyword or the reserved word as entity name or architecture name, but otherwise you can give any name. Again, whenever you are writing entity name or architecture name, that time that name should start with a letter. Okay, it can have numbers also, and then one special character that is a underscore. Okay, but name should not end with underscores. Okay, so all these things that you have to remember. की तुमचं पहिला जे लेटर असणार आहे, म्हणजे पहिलं लेटर जे असणार आहे ते अल्फाबेट असेल. ओके, त्याच्यानंतर त्याच्यामध्ये तुम्ही डिजिट पण वापरू शकता अँड देन अंडरस्कोर पण वापरू शकता, पण शेवटचं जे काही तुमचं लेटर असणार आहे त्यात अंडरस्कोर असणार नाहीये. ओके, सो यू कॅन गिव्ह एनी नेम. अगेन रिमेंबर दॅट इट इज नॉट, VHDL इज नॉट केस सेन्सिटिव्ह, त्यामुळे तुम्ही काहीही लिहिलं तरी तिथे कसंही लिहिलं तरी काही फरक पडणार नाही. Okay, so that is about the name, how to give name to this entity. And then we need to declare ports. Okay, so port here input A, so it is a in mode and then type is standard logic. Okay, here you can use instead of using bit also, but it is better choice to use std underscore logic type because it has more number of possible inputs. Okay, so as and this VHDL is a strongly type language, so there will not be any confusion if another type of that means another input is present at the input terminal. Okay, so this is a good practice to use standard underscore logic as a type. Okay, then B, that is also input, and then it is a in type in mode and then standard underscore logic. Then we have separated these with a semicolon. Okay, and then after that the last Y, that is the output out mode, and it is also a standard underscore logic. Okay, so here this bracket will get completed and then semicolon. Now instead of writing this, as I earlier discussed this, instead of writing these two separate statements, you can write it in this way also: A comma B and then colon in std underscore logic semicolon. Okay, okay, what is meaning of that? जर तुम्ही कॉमा करून हे केलं तर तुमचे जेवढे तुम्ही कॉमाने सेपरेट करणार आहे तेवढे तुमचे पोर्ट्स अवेलेबल असतील. ओके, सो सेपरेट स्टेटमेंट लिहिण्यापेक्षा तुम्ही तसेही लिहू शकता A कॉमा B कोलन इन स्टँडर्ड std underscore logic. Okay, and then this is the end of that entity. Okay, so end and get semicolon. त्याच्यानंतर काय येणार आहे, आर्किटेक्चर. ओके, सो नाउ वी आर गोइंग टू declare architecture body. So here this keyword that we need to write, that is the architecture. Okay, of now here you need to give a name to that architecture. Okay, so I have given here name, that is the and logic of the entity for which you are writing this architecture. तुम्ही ज्या एंटिटी साठी हे आर्किटेक्चर लिहिताय त्याचं नाव तिथे आलं पाहिजे. सो दिस इज अ अँड गेट, त्याच्यासाठी आपण लिहितो म्हणून इथे अँड गेट अँड देन कीवर्ड इज. ओके, and then there is no any declaration that is required, so directly we can start with begin statement. Okay. Now here we are writing this architecture in, that is using data flow modeling. Okay. So whenever we are using data flow modeling, if we that can be done when we have a Boolean expression for the output. If, so here when we are using AND gate, okay, त्याच्यासाठी आपण आता कोड लिहितोय तर त्याचं बुलियन एक्सप्रेशन काय आहे A and B. Okay. uh, so this AND is a keyword or the word that is function that is available in a VHDL program. Okay, so we can directly use that. So here y is assigned to A and B. Okay, म्हणजे जे काही तुमचं आउटपुट आहे ते कशाला असाइन केलं. दिस इज अ असाइनमेंट ऑपरेटर that is a less than or equal to. So whenever you are using this operator, that time whatever is the result of this expression that will be assigned to this parameter. Okay, म्हणजे तुमचा A and B चा जो काही रिझल्ट आहे तो तुमच्या Y या आउटपुटला असाइन होईल. ओके, so depending on the result of that operation and then end of this end logic and then semicolon. So this is the program of AND gate using data flow model. ओके, लक्षात आलंय काय केलं. आता इथे AND OR then NAND NOR XOR XNOR, these are the standard logic gates that are available. So directly you can use that when you are using a or writing a program. Okay, so this is about the data flow modeling. So write down this program. Okay, I hope you are writing this. Yes, or you will write it afterwards. Hello.
Yes, ma'am.
Are you going to write it now?
Yes,
Are you
ma'am.
writing?
Yes,
Okay,
ma'am.
so write this code. Okay. Now here you can see that there are two hyphens that other dash that I have written here. So these indicate that it is a comment. Okay. So for writing a comment, this is used. Okay, have you finished this? Let us proceed.
Okay, ma'am.
Okay. So this is a data flow modeling. Okay. When we are using data flow modeling, whenever we have a Boolean expression for that circuit, then we can go for the data flow modeling. Okay. Another type of modeling, that is the behavioral model. That means suppose we don't know how to what is the Boolean expression for that circuit, but we know the truth table of that uh, circuit, then we can write a behavioral model. Okay, so depending on the logic level at the input of that circuit, what will be the output? If that is known to us, then we can write behavioral modeling type of architecture. Okay. Now, as we know that the truth table of AND gate is whenever both the inputs are at high logic level, then output is high. And whenever any one of the input is zero or both the inputs are zero, then output is zero. Okay. So that concept that we are using to write a behavioral modeling. Okay. So here, first of all, as we know that whenever we are writing VHDL code, we need to declare library. Okay. So the first thing that we need to do is a declare library. So we are declaring library, that is the IEEE. Then we are declaring package to use IEEE dot std underscore logic underscore 1164 dot all semicolon. Okay. So here this package will get added to this program. So whatever all the functions, all subprograms, that are all operators, whatever is present in that package, that you can use in this program. Okay. Then after that, we are going to write entity for this AND gate. Okay, using behavioral model. So here the keyword that will be present, that is a entity. Then of the name for this entity, that is a, I have given it as a and to, and then keyword again is. Okay. After that, we need to declare ports. Okay. So as we know that there are two ports, input ports and one output port for AND gate. So now, as I earlier said, we have declared in this way A, comma B. That means these are the two input, two ports which are of in mode. Okay, and then type is a std underscore logic. Okay, then it is separated with a semicolon. So the another type of port, that is a C colon output and then std underscore logic type. Okay, and then complete the bracket and then semicolon. Okay, so that means end of this port statement and then after that end of this entity and two. ओके सो दिस इज द डिक्लेरेशन. प्रत्येक वेळेला जेव्हा तुम्ही VHDL प्रोग्राम लिहिणार आहे त्या दोन थिंग ज्या दोन गोष्टी आहेत त्या तर कॉमन राहणार आहेत. म्हणजे तुम्ही कुठलंही टाईपचं मॉडेलिंग करा, स्ट्रक्चरल करा, डेटा फ्लो करा किंवा बिहेवियरल करा, पण या सगळ्यासाठी तुम्हाला कॉमन काय राहणार आहे, एकाच सर्किटसाठी जर असेल करत असाल तर त्याच्यामध्ये लायब्ररी डिक्लेरेशन आणि एंटिटी डिक्लेरेशन हे तर कॉमन राहणार आहे. आता याच्यामध्ये आपण जेव्हा लायब्ररी डिक्लेरेशन करतोय तेव्हा आपल्याला फक्त या पॅकेजची गरज आहे IEEE डॉट std अंडरस्कोर लॉजिक अंडरस्कोर 1164. याच्यापेक्षा आपण दुसरं कुठलंही पॅकेज वापरत नाहीये, त्यामुळे त्याचे डिक्लेअर करायची गरज नाही. ओके, फक्त आपण तेवढंच पॅकेज वापरणार आणि त्याच्यात आपण एक सिंपल सर्किट साठीच VHDL कोड लिहितोय. ओके, सो दुसरं कुठलंही पॅकेज आपल्याला डिक्लेअर करायची गरज नाही. त्याच्याबरोबर आपण एमटीडी मध्ये पण फक्त एवढेच आपले पोर्ट्स असणार आहेत तेवढे डिक्लेअर करून घेतोय. आता फक्त आपण चेंज काय करतोय तर आपलं मॉडेलिंग वेगळ्या पद्धतीने आपण करतोय. म्हणजे आपण बिहेवियरल मॉडेल करतोय. आपण इथे बुलियन एक्सप्रेशन वापरणार नाहीये, तर ज्याप्रमाणे ट्रूथ टेबल मध्ये चेंज होणार आहे त्याप्रमाणे आपण आर्किटेक्चर लिहिणार आहे. ठीक आहे. सो आता इथे अगेन वी आर गोइंग टू स्टार्ट विथ द आर्किटेक्चर. सो दिस कीवर्ड विल बी देअर and then name for this architecture. So as I earlier said, you can give any name. So I have given R. Okay. that is the name for this architecture of ज्या आर्किटेक्चर साठी ज्या एंटिटी साठी तुम्ही हे आर्किटेक्चर लिहिताय त्याचं नाव येणार आहे. सो अँड टू अँड देन okay, then it is a start of this architecture. So begin keyword that will be there. Okay, and then here we are going to write a process. Okay, and the sensitivity element of for this process that are A and B. That means these are the two parameters that are going to change in this process. Okay, now as this process we need to evaluate or execute these statements sequentially. So here we are writing it in a process, and then start of this process that will start with a begin statement. Now here we are going to use a if clause. Okay, so if statement that we are going to use in a process. Now we have actually, if you look at the truth table, we have four different combinations of uh, input. Okay, one is the 0 0, another one that is a 0 1, and 1 0 and 1 1. Okay, these are the four different combinations for the input, uh, and then depending on that, our output is going to change. Now you can have this program with four different फोर कंडिशन्ससाठी तुम्ही हा प्रोग्राम लिहू शकता. मग त्याच्याऐवजी मी फक्त असं पण करू शकते की माझा एकाच लॉजिक लेवल एकाच कंडिशनसाठी माझा आउटपुट हाय असणार आहे आणि बाकीच्या कंडिशनसाठी काय आहे आउटपुट लो आहे. सो आय हॅव डिफाईन्ड इन दॅट. ओके, कारण जर तुम्ही प्रत्येक कंडिशन लिहित गेलात तर तुमचं 4 वेळा तुम्हाला ती लिहावी लागेल. सो इन्स्टेड ऑफ दॅट आय हॅव यूज इट ओनली ट्वाइस. ओके, म्हणजे जेवढं ज्या लॉजिक लेवलसाठी 1 आहे तेवढंच लिहिलं आणि बाकीच्यांसाठी 0 आहे ते लिहिलं. ओके, सो व्हॉट आय हॅव डन हिअर, इफ a is equal to 1, okay, so here as this logic level that is to be 1, so it is written in a single quote, and b is equal to, again that means this is the equal to operator that we have used. Then b is also equal to 1, then okay, so this condition will be evaluated, and then the expression that is going to be executed as c will be assigned to value 1. Okay, and then end of semicolon that will be there. If that means if this condition is not satisfied, that is a is equal to 1 and b is equal to 1, then for c will be assigned to value 0. Okay, and then semicolon again, and then end is. Okay, म्हणजे इथे काय होणार आहे, जर a इक्वल टू 1 असेल आणि b इक्वल टू 1 असेल तर c ची व्हॅल्यू 1 असेल. बाकीच्या सगळ्या केससाठी तुमची व्हॅल्यू काय असणार आहे, c ची 0 असेल. अँड देन एंड ऑफ दिस इफ स्टेटमेंट. आफ्टर दॅट वी नीड टू एंड दिस प्रोसेस. सो एंड ऑफ दिस प्रोसेस अँड देन एंड ऑफ दिस आर्किटेक्चर. ओके, सो दिस एंड ऑफ आर्क. So that will be semicolon. That will be present at the end of this statement. So this is the behavioral modeling of AND gate. Okay, लक्षात आलंय तुमच्या काय केलं ते?
हो मॅम.
Yes, everyone got this? Okay. So
Yes,
I will
ma'am.
show you now. Okay. Code for this OR gate. So before that, before displaying this, okay, are you going to try for data flow modeling for OR gate? So
Okay,
write
ma'am.
a code. Okay, so try it and then we will discuss. Okay, so write this code also, and then after that try writing code for OR gate. I hope you have completed writing for this code, behavioral modeling of AND gate. And then I am displaying logic of OR gate. Okay, and you have to write code for this gate. Let me know once you finish writing, then we will discuss further. I hope everyone has commented in chat box your roll number and name. Okay, finished? So now we are going to discuss about how to write or get data flow model. Okay. So as we have already discussed, first of all, we need to declare library, then packages that we are going to use. Uh, that also we need to declare. So here we have declared library IEEE, then use package that we are going to use, that is the std underscore logic 1164.org. Okay. By default, we use this package. Okay. ते package आपण प्रत्येक प्रोग्राम मध्ये यूज करणारच आहे, त्यामुळे तुम्हाला ते डिक्लेअर केलं. Okay. So this is library declaration. Then after that, we are going to declare entity. As for a OR gate, we have two inputs. One is the input A and B, and then one output, that is Y. So we have given these names to this port. So port declaration for this entity, and I have given the name for this entity as a OR gate. As I earlier said, you can give any name to this entity. Okay, just remember that you have to use the same name when we are going to declare architecture. Okay, so this is a entity or gate is, then port A, that is the in mode, then standard logic, that is the data type, and then semicolon, then another port B, that is also a input port, and then standard logic, semicolon. Okay, so you have to remember this syntax whenever you are giving a name to this port. So for port declaration, the name, port name, then colon, and then after that type of that port, mode of that port, and then type of that. Okay. So here it is a in mode, input port, and then std underscore logic data type. Okay. So similarly, you have to declare it for the another port, and then y, that is the output port, and then standard logic data type. Okay. Then bracket complete. So here we have declared all the ports. So completed this bracket, and then semicolon, and then end of this entity or gate. And after that, the architecture that will be um, for OR logic, that is the name used for this architecture of the entity or gate is, then begin, and then y is assigned to A or B. Okay, so here this is the keyword that is used for the OR gate. Okay, so this OR will do the OR functioning. Okay, or and then end of this OR logic architecture. So here very simple program that is for the data flow. हे जर तुम्हाला बुलियन एक्सप्रेशन माहिती असेल तर तुम्हाला VHDL प्रोग्राम लिहायला खूप इझी जाईल. बट ऑल द टाइम्स वी कॅनॉट यूज दिस बुलियन एक्सप्रेशन, सो वी गो फॉर द अनदर टाइप ऑफ मॉडेलिंग. पण जर जेव्हा जेव्हा तुम्हाला बुलियन एक्सप्रेशन माहिती असेल तेव्हा ते लिहिणं जास्ती सोपं जातं. पण काही वेळेला असं होतं की जेव्हा तुमच्या सर्किटमध्ये खूप सारे गेट्स आहेत, म्हणजे तुमच्याकडे अगदी आता तुमचं सर्किट आहे की ज्याच्यामध्ये 4 अँड गेट आहेत, 5-6 ऑर गेट आहेत, त्याच्यानंतर नॅन्ड गेट पण आहेत, आणि एवढ्या सगळ्यांसाठीचं बुलियन एक्सप्रेशन लिहिणं अवघड जातं. ओके, आणि मग तेव्हा तुम्हाला डेटा फ्लो मॉडेलिंग नाही यूज करता येत, तर दुसरं कुठल्या तरी टाईपचं मॉडेलिंग यूज करावं, म्हणजे दुसरा तुम्हाला बिहेव्हिअरल मॉडेलिंग यूज करावं लागेल. आणि ज्यावेळेस जर तुम्हाला ट्रूथ टेबल माहिती असेल तर तुम्ही बिहेव्हिअरल मॉडेलिंग. ओके, अँड इफ यू नो स्ट्रक्चर ऑफ दॅट सर्किट, ओके, म्हणजे तुम्हाला माहिती आहे की स्ट्रक्चर काय आहे, तर देन इट इज बेटर टू गो फॉर द स्ट्रक्चरल मॉडेल. But structural modeling is bit difficult than that of this data flow modeling and behavioral modeling. So most of the times we use data flow modeling and behavioral modeling, but also for large circuits we use structural modeling. Also we can use mixed modeling type also. म्हणजे याच्यामध्ये आपण डेटा फ्लो मॉडेलिंग त्या बरोबरीने दुसऱ्या टाईपचे पण मॉडेलिंग यूज करू शकतो. सो दॅट ऑल्सो वी कॅन डू वाईल रायटिंग अ आर्किटेक्चर. सो दिस इज अबाउट द डेटा फ्लो मॉडेलिंग. आता जर याच्यामध्ये मला बिहेव्हिअरल मॉडेलिंग करायचं असेल तर मला चेंज काय करावं लागेल?
ट्रुथ टेबल.
आय डोंट वॉन्ट ट्रूथ टेबल प्रमाणे तुम्हाला लॉजिक लिहावं लागेल. ओके, सो हाऊ दॅट प्रोग्राम विल बी. Okay, so this is the program for behavioral modeling. Okay, so what you entity declaration and library declaration that will be same as that of the earlier. Okay, फक्त तुमचं चेंज काय होणार आहे? आता जेव्हा तुम्ही बिहेव्हिअरल मॉडेलिंग म्हणता तेव्हा तुमची काय चेंज होणार आहे? आर्किटेक्चर चेंज होणार आहे. ओके, सो हियर इन अ आर्किटेक्चर when once we start the architecture writing, so here we need to define the process whose sensitivity elements that will be a comma b. म्हणजे इथे चेंज काय होणार आहे? जे एंटिटी मध्ये आपण पॅरामीटर्स डिक्लेअर केले किंवा पोर्ट्स डिक्लेअर केले ए आणि बी, ते चेंज होणार आहेत. ते कशाप्रमाणे चेंज होणार आहेत? आउटपुट प्रमाणे. ओके, सो हियर आय हॅव गिवन द नेम सी फॉर द आउटपुट. ओके, जस्ट रिमेंबर दॅट आय हॅव गिवन नेम सी फॉर द आउटपुट पोर्ट. ओके, नाउ व्हॉट इज द लॉजिक बिहाइंड द ऑर गेट? ट्रूथ टेबल त्याचं काय आहे की त्याचे जेव्हा when both the inputs are 0, output is 0. Okay, but if any one of the outputs or both the outputs are 1, then output is 1. Okay, so here while writing this process we have used if statement. Okay, so if a is equal to 0 and b is equal to 0, then c will be assigned to 0. Okay, else c is assigned to 1, and then end of this if, then end of this process and end of this architecture. Okay, so this is the behavioral modeling of OR gate. ओके, लक्षात आलंय? आता इथे तुम्ही प्रत्येक केस सुद्धा लिहू शकता. म्हणजे इथे आता आपण फक्त काय केलं, दोनच केस मध्ये वापरलं. इफ a is equal to 0 and b is equal to 0 ही केस वापरली. Then c is assigned to 0. Now you can go in this way also. Else if a is equal to 0 and b is equal to 1, c will be assigned to 1. Okay, else if a is equal to 1, b is equal to 0, then c is assigned to 1, and then you can go for else if c is assigned to 1. Okay, so in that way you can go, but instead of writing those many statements we have minimized that and then we have written only these two statements. Okay, म्हणजे इथे फक्त आपण एकच कंडिशन वापरली, else दुसरी वापर. Okay, so this is about the behavioral modeling of OR. Okay, Now, this is for your homework. You have to write data flow modeling and behavioral modeling for remaining gates. Okay, that means NAND, NOR, XOR, and XNOR. Okay, so for all these gates, you have to write data flow modeling and behavioral modeling. Okay, is it possible for you?
मॅम रिमेनिंग सगळ्या गेटचं लिहायचं का म्हणजे
हाँ
नॉर
हाँ
नॅन्ड.
जसं येस 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 सगळ्या गेटसाठी लिहा म्हणजे तुमची प्रॅक्टिस होईल तुमच्या लक्षात येईल की आपण आणि तो सिंटॅक्स कसा आहे हे लक्षात येईल ओके सो फॉर दॅट यू राईट इट
आम्हाला कारण भेटलं आता.
ओके
ओके मॅम
ओके
चालेल.
ओके so now we are actually proceeding. Okay, so this is just the basic concept how to write a data flow modeling and behavioral modeling for any simple circuit. Okay, इथे फक्त एकच गेट होतं त्याच्यासाठीच आपण केलं. Now we are proceeding towards actually how we are going to write a VHDL code for different circuits. Okay, म्हणजे आपण हाफ ॲडर साठी फुल ॲडर साठी कसं लिहायचं हे बघणार आहे. ओके, so without the time permit. Okay, only 5 minutes are there. So I'll just start with this statement and then we will proceed in the next lecture. Okay, so this is a adder. Okay, so we are going to discuss about adder now, how to write VHDL code for adder circuit. Okay, now what is mean by adder? The circuit which performs addition of numbers. Okay, so in most modern computers, this adder that is present in arithmetic logic unit, that means in ALU. Okay, so I think almost all the circuit that does this operation, that is an addition. Okay, so there are two types of adder. One is the half adder and another one that is a full adder. Okay, so half adder, that means it accepts two binary digits of its input and produce two binary digits output. One is the sum and another one that is a carry. Okay. So we will discuss in detail about this circuit in the next lecture. Okay. So for today we will stop here. Mm. So for today, this is your homework that you need to write a code for remaining logic gates. Okay. So is there any doubt?
नो मॅम.
So let us stop here for today. And we will discuss about actual VHDL model for different combinational and sequential circuits from the next lecture. If you have not commented in chat box, comment it so that I can stop recording. Others, those who have commented, they can leave this meeting. Okay, so I will stop recording now.